Okay, so let's look at the following trig identities. For the tangent identities, I will cover that all in a separate video. So when we're given sine x plus y, we can rewrite this as sine x times cosine y plus minus cosine x minus or multiply sine y. Now, one thing's important to note here, that the order, so the order of multiplication doesn't really matter. It's like a multiplication property. And plus minus, which means if I have, let's say, 60 plus 45, then I'll have a plus symbol over here. Let's say I have 60 minus 45, I'll have a minus symbol here. Now for cosine, you're going to use the reciprocal symbol, okay, in the identity. Look, so if I have cosine x plus y, I get cosine minus sine. Okay, same thing for cos. If I have cos x minus y, I use the reciprocal symbol, which would be positive. Okay, well, first things first. In order to make these calculations a bit easier for yourself, I would recommend, I don't necessarily believe in memorization, but this is one thing I would recommend you to memorize. These two triangles. So across from 30 is 1, across from 60 is square root 3, and the hypotenuse is 2. That's a special 60, 30, 90 triangle. Then you have a 45, 45 triangle, 45, 45, 90, which is 1, 1, and the hypotenuse would be square root 2. If you can remember these two triangles, these equations become very simple. Okay, so let's do some examples to test our identities. So let's do number 1. So let's start with the basic one, the sine of 30. So let me show you how to use this triangle. So we know that sine of theta is equal to my opposite side over my hypotenuse side. In this case, opposite from 30 is 1. Okay, so that would give me 1 over a hypotenuse, which is 2. So in this case, sine of 30 is equal to 1 over 2. What about if they give us the sine of 75? Well, how do we find this one now? Now the sine of 75 I can rewrite. I can rewrite this as sine 45 plus 30. Okay, 45 plus 30. Now we're going to use our identity, this one. Okay, because look at that. X plus y is equal to my value given. Okay, so let's do it. So we're going to say the sine of 45 multiply the cosine of 30, and we're going to say, let me move down, plus the cosine of 45 multiply the sine of 30. So sine of 45, if I can give you a little tip, sine 45 and cosine 45, I've already proved this in one of my previous trigonometry videos, so you can just go watch it. You obviously have to understand the ratios before you can do identities. So cosine 45 and sine 45 would also always be square root 2 over 2. Always. Okay? I can quickly do it over here. Why is that the case? Because 45, which would be my opposite over, so I get 1 over square root 2. I can multiply both sides by square root 2, or both my numerator and denominator. This gives me square root 2 over square root 4, which is therefore square root 2 over 2. Okay? So let's go do this. So sine 45, that gives me the square root 2 over 2. We're going to multiply this with cosine 30. Cosine 30 is, let's see, adjacent over my hypotenuse, so that's square root 3 over 2, plus cosine 45, as I mentioned before, square root 2 over 2. Sine of 30 is 1 over 2, so that just gives me 1 over 2. And now we can do some calculations. Well, what's the square root of 2 multiply the square root of 3? That's the square root of 6. 2 times 2 is 4. Plus square root of 2 over 4. And now since I have the same numerator, I can join this up into one fraction. over 4. Where did I get the square root 2 from? I got the square root 2 from saying square root 2 multiply 1 is square root 2. And this will be my final answer. Usually these type of questions are asked for you to solve it without a calculator. So just keep that one in mind. Okay. Let's do the exact same example, but for cosine. Let's say the cosine of 75. Now the cosine of 75, we can rewrite this as cosine 45 plus 30. And now let's follow our identity above. Okay, so our identity is going to be, I can rewrite this as cosine 45 times cosine 30. And now remember, since there's a positive symbol over here, we're going to use the reciprocal. Okay, the sine of 45 times the sine of 30. Okay, now we can just use these values above. Okay, we've already found all the values. So cosine 45 square root 2 over 2. I'm going to multiply this with cosine 30. Now let's go find cosine 30 quickly again on our triangle. Okay, so 30 is over here, so this is going to be now theta. So square root 3 over square root 3 over 2. Minus sine of 45 is square root 2 over 2. And sine of 30 is 1 over 2. So again, we get square root 6 over 4 minus square root 2 over 4. So in this case, I have the square root of 6 minus the square root of 2 over 4. And now this would be my final answer. Okay, let's do one more example. What about if I'm given, let's see, the cosine of 120. What if I'm given to the cosine of 120? Well, the point is, the main thing we want to do here is we want to find known angles. We want to find known angles. What does this mean? Well, we know what's the value of cosine 45. We know what's the value of cosine 60. We also know what's the value of cosine 30. We also know what's the value of cosine 90. So we want to try manipulate these values into giving me this 120. Let's say, for instance, I ask you to go calculate cosine 21 without a calculator. This is going to be very, very complicated. So we can use this method to solve these type of equations where we can break this up into addition or subtraction and with known angles. Okay, that's the idea behind these identities. So cosine 90 plus 30 gives me 120. So now let's follow our rule. Let's follow our identity. So I can say the cosine of 90 times the cosine of 30 minus, remember, reciprocal, minus the sine of 90 and the sine of 30. Okay, so now look at this. I made a video about the unit circle as well, and I would highly recommend you go watch that video if you're unfamiliar with the unit circle. So in this situation, I need to find 90. Well, my 90 degrees is going to be between quadrant 1 and 2 on this y-axis. So over there, I have my 90-degree angle, and this point is 0, 1 in trigonometrical functions, since it just makes a circle. Okay. Now, my 0 relates to my cosine value, and my 1 relates to my sine value. So what does this mean? Well, this means that the cosine of 90 is 0 and the sine of 90 is 1. Now we can use this all across at every single point. Here you would have negative 1, 0, 0, negative 1, and then 1, 0. So you can always use these identities, especially if your knowledge on unit circles is quite advanced. I mean, not really advanced, but you know, anyway. So let's do this. So the cosine of 90, as we've just seen, is 0. So we're going to have to multiply 0 with cosine 30. So what exactly is cosine 30 again? Well, it's square root 3 over 2. So this gives me 0. Anything multiply 0, 0. Sine of 90, we can see, is given as 1. Okay, and sine of 30 is 1 over 2. So it's going to be minus 1 over 2. So my final answer should be negative 1 over 2. Now we can actually confirm this on a Casio. All we do is type cosine 120. If I type cosine 120, I can see it's 1 over 2. But you need to be very careful because in exams, you might see the following. Again, whether it's IB exams or whether it's standard exams, Cambridge exams, you'll see this thing. You'll see like maybe a little calculator over here. This is in the IB exams or in the IB worksheets especially. You'll see this. This means you're not allowed to use calculator. Okay, or they'll just make a statement, no calculator. And what happens is if you just present this final answer, okay, if you just present this answer, let's say this mark scheme is 5 marks. So let's say you get a mark for this, you get a mark for that, for this, this. Okay, let's make it about 7. What would I usually assign? Maybe 6 marks, depending on the grade. Okay, so maybe 1, 2, 3, 4, 5, 6. So you get 6 marks. Now what happens if you only write negative 1 over 2? Well, as an educator, we can obviously see that you used calculator. So it depends. Some educators might be generous and give you a little 1. Others might be, since the instructions say no calculator and you used calculator, might give you a nice little 0. So it's worth learning these identities. Anyway.